Okay. Okay, so May 28th, OOP345NDD. Okay, that's that. And let me open up the Blackboard. Log in. So this is what's going to get available to you, courses. And you need to start doing it now, not now, after the class. So under quizzes, this is the first thing, visible to students. Okay. So make sure you open this one and actually go through it and see what it says and how you're going to do the test when the time comes. And the next thing is the agreement that you're going to do. Now, the agreement over here, let me set up the due date for it. So your class starts at 3:15 on Friday, right? Or 3:15, right? I think so. 3:20, yeah, 3:20. So set this one to Friday. And this is going to be 3:20 p.m. So it means if you come to class not doing this, then you can't do the quiz, okay?
The date is set to January.
Oh, did I? Oh, okay. Yeah, one more time. That's better. Okay. Thank you, whoever it was. Okay, so that's that. Save, change date. So I'm going to edit this and I'm going to say extra credit. No, extra credit? I don't know. I think I have to first do it. But anyways, when you start, this is 0 points. This is just for testing. What counts is this question. So I put the YouTube video of how the tests are done. We've done it in class, but I'm going to over here. It kind of tells exactly what it is. Then you have to select option A and then click. That means agreement. Now, this becomes prerequisite to all your programming tests. If you don't agree to this, you can do option B. I do not agree and would like to drop the subject. So one of the two choices that you have. So you have to agree to this to be able to do the quizzes. I know it kind of looks like a little bit harsh, but hey. So that's that. Cancel. Save is not a cancel over here. Yeah. I think we're good. Yeah. So I will make it available. I'm going to go home, make sure that the reason is that if I just leave it like this, then although the mark of the first one is 0, is for practice. So you can go to any lab and do this. I'll make sure that it's available to you. I'm going to actually make it available. You start doing it, and then I'll fix the rest. So visible to students. You can start doing it anytime you want. And click on the agreement. But please just don't click on the agreement. OK? See the video. Today, 2 students had to leave the test because we started the test, and everybody's on their computers. They started doing on their own laptops. And the very first thing that I'm saying is that you are doing it on a computer. So they had to leave the class. So careful. It's not a very difficult task to go through. Please take a look at it, and that's that. I started marking workshop 0 and sent few feedbacks here or there. caught two people cheating on a test that is an assessment. I mean, seriously? Like, I asked you to write some C++ code so I can assess your knowledge and give you some feedback for your studying, and they copied someone else's thing and gave it to me. Really? I mean, what does that, I mean, I don't understand it. Like, you want to fake your knowledge? I mean, like, the one that I want to give feedback to? I don't know. Anyways, that's a good impression. So they are like on the microscope for all the other things that they're going to give me. But it was kind of funny, actually, quite frankly. I don't understand the reason behind it. But anyways, that's that. So please, the feedback that I'm going to give you, you got to get it by the end of the week. Everybody keep asking me, what is the due date for assignment 1? Please go on Matrix, log in, type the submission command, and add a -do at the end. It tells you when the due date is. Different subjects, different students have different due dates based on their status. So it's not, it is next week, I think, but exactly what day and time and stuff, please take a look at it. So that's that. And let's continue with the rest. So let me just open something here. 3, 4, 5. Let's first talk about move semantics. So we understand exactly what we need to do. If you recall, earlier in the semester, we talked about L values and R values. So essentially, I think it was here, or somewhere around here. No? Yeah. L values and R values, and that's not the one. Maybe it's this one. Yeah. So we mentioned that when you actually use the R value reference to create a reference with which 2 ampersands, compiler can understand what is being passed is actually a temporary thing. So in line 13, when you are saying print, you are actually putting a C string. But what print is receiving over there is an object of type string. So to be able to match this to that, compiler requires to create a temporary nameless string, not C string, string out of this constant character pointer and pass it to print. And that becomes an R value, an object that is about to die. And because it is about to die, it can be detected with an R value reference. We're going to use that to our advantage today. So what I'm going to do is this. I'm going to create a class, add a class over here. Let's call that class a record. Illegal characters in it. Oh, sorry. Record. Class name record, yeah, sorry. Class name record, okay. So it actually creates a record class for us. And what I'm going to do, I'm going to actually create a dynamic class over here, kind of something that we have done in OOP345. So essentially, what I'm going to create is something like this. Take a look. I'm just organizing it so I don't have to type it over here. Okay, so this is what I am creating. I'm not going to create the namespaces and stuff because I want to just teach the concept. So essentially, this is the class that I'm creating, and this is what you're going to have. It is literally an OOP345 review for rule of 3, where essentially we say that any class that holds data outside of scope needs to take care of it because the compiler won't in assignment and copying. That's why at line 7 we actually create what we call it a copy constructor, and at line 7 we create a copy constructor. At line 8 we create a copy assignment. And obviously because it has data that it keeps outside of the scope, it needs a destructor to take care of it within scope. Very simple and straightforward. So going back again to what we have done previous semester, I need to implement these rule of 3. In rule of 3, I implemented as follows. Just split the window. So is it visible, the code back there? Online people? Everything's good? If it's too small, let me know. If not, then we're going to proceed like this.
It's fine.
Oh, perfect. Thank you. So, creating the constructor and the copy constructor, straightforward thing. Again, I'm not doing all the fancy stuff. I'm not going to. So for the constructor, as you see over there, I'm receiving a data, passing a data, receiving a data through arguments with record. I'm not checking to see if it's null or not. I assume it's null. I just want to focus on copying and creation of the object. So as you see, I'm creating, I am allocating enough memory for the data that is coming in, and I'm copying it. And in a copy constructor, we do the standard thing that we've done before, which means because the record's not copying itself using what the system does, I first measure the other data that is being copied and allocate enough memory at line 14 over here, and then at line 15 I'm going to copy that data. That C-log thingy that you see I'm printing over there, C-log is C-out sister, okay? They work the exact same way, absolutely no difference. The good thing is that I can turn it on and off without affecting C-out. So I can easily set C-log into an error state, and if I do that, then it becomes disabled and it won't print anything. So I can turn off the debugging messages on and off. Not a good practice for real stuff, okay? For real coding, you don't put debugging codes like that and leave it in the code, okay? If you are actually doing that, you've got to do preprocessor directives that we're going to learn at the end of the semester, not now, okay? So C-log is actually printing that it's printed over there for us, and that's that. And then we need copy assignment. Copy assignment is the exact same thing as copy construction, but the difference is that because now the object is not being copied, it's very possible that by mistake or intentionally an object is being assigned to a reference of its own, and therefore I have to take care of that by making sure that the address of me, which is line 19, my address is not the same as the other, which means we are not the same things. In C-log, I'm printing assigned this, which is me. Then I'm going to delete the data. So the 3 lines, 21, 22, 23, is the actual code. The other 2 is just messages, so we see how things are happening. So first I delete my own data because now I am an already existing object being assigned to another. At line 13, which is the copy constructor, I'm a new object. A new object being copied, I have nothing. I'm an empty object, so I don't need to do anything. Where in line 18, when I'm assigning myself, it means I already have existence, I may have data. Because of that, I delete my data first and then do the rest of the stuff, like the copy construction. And that is copy assignment. Obviously, we need to take care of the data when we're gone, which is the destructor. There's no big mystery over there. You're deleting the data when you're gone, no problem. I want to display what I have in here, so all those display thingies work. That's why I'm going to create a display. And the display actually checks if there is data, it's going to print it, otherwise it's not going to do anything. And that's the display. Standard O-stream insertion, which is covered in the insertion operator overload. And that's that. And that's essentially an OOP345 rule of 3. Anybody have any problem with that? We good? All right. To test this is what we're going to do. So I'm going to create a function, and this function of mine, its job is to print a record. And obviously in here I need to include record, record.h. Okay? So print receives T, prints the rec by value, okay? And this is the record. So I'm testing all the good stuff that I'm supposed to do with this. So essentially I'm going to create, so I can actually do this. So I'm going to create, I'm going to say record. R is set to that, so that's going to create the record, right? And then in here I'm going to say print R and see what happens, okay? Running all these, we'll see that I get an error. Let's see, what is the error? Oh, STR copy. Goddamn thing, where is it? It's in which file? Record.cpp, record.cpp. Yeah, oh. What the heck is that? That was the reason, I think. Okay, let's rebuild. Oh, that's T. That's supposed to be rec. Control F7 to compile. There we go. Now let's run it. And this is what I have. So essentially, when R is called, we know by default this is what happens. So when a function is called, we have print R equals to print rec, record rec equals to R. This is what happens when a function is called, always. So essentially, the arguments of the call of the function that is being called will be set or initialized to values you're passing. And because in this case I'm actually doing it this way, therefore assignment at the moment of creation is a copy constructor, therefore it's going to get copied. And that's where you got that message. So it's going to say copy May 28th. It is when it's copied over there. Then afterwards it's going to assign S in print, which is S in print as you see, to May 20th, yada yada. Then it's going to print it out. And it comes out. Are we good? Okay. Now, you see over here it's actually returning S by value. You see that? Now this is optimization. If this program was, if I executed this program 15 years ago, At line 9, a copy constructor would have been called 2. Think about it for a second. If I said over here R is set to print and then, okay, now at line 15, are you comfortable that I put R over here, or should I create a new one? This doesn't bother anyone, hopefully, when I do this. Are we okay? Okay. So at line 9, I'm saying print R. So R goes over there. It gets copied into rec, right? Then it comes into, S is getting created using the one argument constructor. Now assignment is called at line 7. It's printed. Now S is returned. Correct? Now when S is returned, microphone. Okay. What is the scope of S? Where the S is created.
It's created in, I would say, in record?
Inside print, right?
Inside print, yeah.
Inside print. So the scope of print, a scope.s is print, correct? Right? Now, take a look. At line 15, S is being returned that overwrites R. Do we all agree with that? And we just mentioned that the S's scope is print, right? When S is returned, print has ended, correct? If it's ended, S is destroyed. How can it return it? Think about it. All the things that we studied in OOP345 and IPC, we return something, right? You create a local variable and you return it. How can it return when it dies in the function? That's the thing. So right at line 9, because S is a local variable and it's going to cease to exist when the printout is over, what the compiler does, it creates a temporary nameless object of type record and copies everything from S into it. Then print at line 15 ends. R becomes equals to of a temporary nameless object with the same data of S. Then that temporary nameless, R will be set to that temporary nameless. Then temporary nameless dies. R has the value and keeps going. That's the amount of process goes around when you return something by value. Now compilers are more smart. When they see you have done something like this, they simply say, okay, the S is about to die, right? And then you want to create a nameless out of it, then why do I kill it? I'm going to make it nameless instead of doing that, and then do the copying. So nothing will be copied over there. The compilers didn't do that before. 10, 15 years ago, they didn't do that. No matter what you did, if you returned something, a copy constructor would have happened. Or they are even getting smart now. If I say over here, so now something is being passed to print. I'm not getting any error, but I'm not passing a record to print. What happens in here? So essentially what happens would be this, right? Therefore, again, rec in old times, it would upcast this actually to a, record, then copy that record, then it would kill it. But now it's playing it more smart. Okay? So in here I'm going to say clog created this. Just have a log when it's created. And in here I'm going to say clog deleting this. So now when I run this, you will see the number of stuff happening over here. Like created this, then so created, main thing at the beginning. Then it created something. So as you see, nothing is copied. Then it created S in print. So literally what I told you happened, which means rec got initialized by something. That's why it says created something. And deleting, and as you see, no copying is happening over here, which is good. Okay? So, yeah. Now we're going to talk about coffee. So, talking about coffee, anybody have over here a mug that I can borrow? Don't worry, I'm not going to put anything in it. Yeah, can I borrow it? I'm not going to put anything in it, just want to demonstrate something. Okay, so, wow, there's stuff in it. Okay, so I have a cup of coffee. And let's say this is another cup of coffee. Okay. In old times, if I wanted to give this to someone else, a function return the cup of coffee, what will happen is that you have to create a cup of coffee first. So let's say these two are identical. So you have nothing, you have only a cup of coffee. If you are returning it, so this is the print that was returning something over there. You have to create another piece of coffee over like this. Then you have to brew coffee exactly like the one that I have inside here. You don't just pour it in there. You have to make a coffee that is identical to this one. Put it in this one. That's copy construction. Then it would go away. Then this coffee is thrown away. You can see how much coffee is being wasted in here and how much time and effort you have to spend to actually brew new coffee. But if this is in print and I'm returning the coffee and I'm not going to need this anymore. Okay, sorry, the screen suddenly went off on it. Yeah, so if this is in print, and as you see at line 9, it's S is being returned. After that, I don't need the damn thing. Why do I brew new coffee? I can simply have an empty cup of coffee, and I can just pour this one in that one, which means move the coffee from this one into this one. Now you didn't brew any coffee, and you have a coffee exactly like mine, what I had before. Now I can just throw the empty cup away. So lots of time is being saved over here brewing new coffee. Do we understand this? Hopefully. Okay. So that's that. That's how move semantics actually work. We're going to learn to detect if a cup is disposable and is just about to die and it's going to go to garbage. I don't create a copy of its content. I simply empty the content if I want. And we learned how to do this. using, we learned how to do this using the L value reference. So essentially, in here, instead of creating a copy constructor, I'm going to create a move constructor. What does a move constructor do? It is exactly the same thing. So we have record, but instead of constant, I'm going to pass it a non-constant reference. Why? Because I want to empty the other one. I have to modify it. It's not constant anymore. So this is going to be a record, and I'm going to put 2 of these to make sure the one that is coming in is actually an R value. And then I'm going to say other. So what happens whenever the other one is a disposable object, I'm just going to get its contents. How to code it, we'll see. So, sorry. Whenever a disposable object is being passed, the compiler can recognize which function to call. If it's not disposable, it's line number 7 that's going to get called. If it is disposable, it's line number 8 that's going to get called. Remember the string thingy that we created? It's the same. Now I can do exactly the same thing with the assignment operator. And say, when I'm being assigned, if the other one is a disposable object, just get its value. Don't copy anything. Representing rule of 5. So rule of 3 was copy constructor, copy assignment, and destructor, right? Rule of 5 says copy constructor, copy assignment, move constructor, move assignment, and destructor. That not only makes classes with resources safe to be copied around, but it makes it fast moving it around. How do we implement it? Luckily, the implementation of moving is much, much simpler than copying. So for example, for move constructors, what do I do? First of all, it's a brand new object I'm creating. And I'm using other things' data. So I don't need to worry about the data that I already have. So what I do over here, I simply say, hey, I'm going to I'm thinking if I should draw something first. Maybe I should. Let me just draw something first. So old times, this is what we had. We had a pointer. A pointer pointed to some piece of data, right? And then we wanted to have that data, so we created another pointer to have that data. First, we measured to see what is the size of the data. That's too big. Measured to see exactly what the size of the data is. Then we copied all the data from the old one to the new one by one, right? And afterwards, we had a copy of the other one. So life was beautiful. There you go. That was copy constructor that we have done, right? In move constructor, this is what we do. This is when I want to move the data, right? I'm going to simply say, hey, I'm going to point to the same place you pointed. And I'm going to make this one null. Done. I own the data, you don't. Data is moved. So that's what we're going to do. So now we're going to say, OK. First, show me the money. So first, show me where the data is. M data is equal to other than other M data. Now, I'm pointing to their data. And I'm going to say other data. You got nothing. Done. You can see from the content of the top and the bottom how quick moving can be. The top one shows the copy semantics, copy logic. First, dynamic memory allocation. Oh my God. Allocating memory is a very expensive thing to do. You have to ask the OS. OS has to see where the empty, where is enough contiguous memory site so it can actually get the memory for you. And then you got to get the memory. Then you have to go through every single, so SDR copy, is essentially a loop, right? It has to go through every single element of the other one and put it in here. Then you have copied everything. In here, I'm just going to say, I've got yours, you got nothing. Done. So I'm going to say, I move this. Okay? For the move assignment, the logic is saying, first of all, if I am not the other one, I'm going to move. Otherwise, it's nuts. I'm not going to do that, right? So I'm going to say, if I'm not the other, do the moving. Otherwise, what is else? No else. Just return this. Okay, so that's that. Now what we're going to do, now the difference is that now I exist. I already have data, so I have to take care of the old data. That's the only difference. I have to say, delete me. And after deleting me, the logic is the same. So first wipe out my data, then I take the ownership, then you have nothing. And I have everything now. Okay? So essentially, okay. I'm going to say this, which is what I have over here, is, and at the end I'm going to say move assigned to this. So essentially I'm showing the data was this, now it's moved to that. And that's that. You see over here, this particular thingy over here says, it might give you a warning. I want to see if it's going to give you the mark. Yeah, you see it says, this kind of function should not throw. Declare it as no exception. Because we don't know what exceptions are, still I'm not going to mention it. But you write const over here not to make constant values, right? Soon we're going to learn what exceptions are. And when we do that, you'll see that these type of stuff are not supposed to throw exceptions. Move constructor, move assignments. Therefore, you're going to write no except. You write over here. We'll see that later. If you don't write it, doesn't matter. When we learn exceptions, then you know that you can write it. It means you guarantee that it's not going to throw an exception. If you throw an exception over there, then it's going to be fine. Anyways, I'll teach exceptions later on. So we're good. Do I have anything else over here? Deleting this and that. That's good. Yeah, I think we're fine. So let's run this. Also, nothing happened, nothing different happened over here. Now I'm going to do this. I'm going to say record. What do I do? Record S is something. No, not something. Somebody. Now take a look. Now I'm going to say record T move S. So I'm going to write over here C out S. And in here I'm going to say C out S. I need to actually print the S. And T. So you will see that, first of all, the move constructor is going to get called. First of all, the move constructor is going to get called. You see S some value. Look at these. Okay? S some value. It moves some value. So T will have that value and S will have nothing. So essentially, I moved it to the other one. Okay? And the same thing as assignment. So now I can say, I can bring R over here too. Now I can say T is equal to move R and show T and R afterwards. You will see that at the end, some value is move assigned to something. And then so T is something, some value, R is something. But when you go down, T is something and R has nothing. So essentially the value of R is now moved to the other one. And that's move aside. That's it. Those are the semantics. And it's from now on, whenever you have dynamic memory allocation, that's what's going to happen. So the quiz that you have the next day, I'll tell you what the contexts are, send you a documentation. That quiz is going to be on association, aggregation, and yada, yada. You'll know what the question is before you do the test. So I'll post the question tonight too. So you're gonna see what it is. But for next week, actually I'm adding one quiz. You're gonna have one more, not 4 quizzes, 5. So next week we're gonna have a quiz. The week after you have another. The week after I have another. That's 3 quizzes, and then you're gonna have your midterm. Okay? But I'm gonna make the questions shorter instead of give you one big one, so it's easier to get marks. Okay? And next week you're gonna have rule of 5. So I'll give you exactly something like this. I'll give you a class with some dynamic value in it, and I'm going to say apply rule of 5 to it. You just do the rule of 5 and you're good to go. Okay? Questions? Anyone? Yeah, yes.
Is the rule of 5 included in the course notes? Is it included in the course notes?
Yeah, somewhere. I don't know.
I'm trying to find it.
I don't know. I don't know. Yeah, probably when we were talking about references. Yeah, I don't follow the sequence that you have in it, because whenever something becomes needed, then I'll talk about it. So that's that. Are we good down to this point? Questions? Suggestions? Objections? All right. So that was rule of 5 that is in the record. Now, let's go back to C language, not even C++. I'm going to go back in history. So this one was 01, rule of 5, the CPP. Okay, let me open up my cheat sheet, because it's like 1.5 million things that I have to go through. Actually, what I'm going to do is this. Let me just show you that I'm going to bring this up. Okay, so 1, 2, 3, 4, 5, copy. I'm going to put 5 projects in here. These 5 projects implement a class called int, int, capital I. Its job is to encapsulate an integer, a validated integer. So integers are integers. I create a class that is a validated integer. Its job is to validate an integer. That's all. But just we're going to bring it up after we go through all the lectures and things that we need to talk about. So let me put all these things over here. Number 1, document selector. Where is it? In IPC 1, sorry, in OOP345, what's going on? Are we okay? No, okay. So I'll go through this and I'll give you a break, okay? So in OOP345, one thing I have to mention that I forgot before bringing this up. Functions in C++, in C++11, they have another type of prototype. You see that print thingy that I wrote over there? Okay, I can actually do this. I can say auto print that returns a record. And in here I can say auto main that returns an int. Potatoes, potatoes. So essentially you're saying, why did they do that? We're going to learn later on when we actually go deep into templates and understand like a standard template library. We're going to find out that sometimes when you create templates, the outcome of template does not dictate what the return statement is. And because of that, you cannot have the return statement here. You have to have it after. So the compiler, after knowing what the signature is, decide what the output is. Okay, let me explain. Damn it. Okay, so I see question mark in people's face. That hurts me. Okay, so I'm saying template type A and type name B. Okay, now I'm going to say over here, what if I want to have add A and B, and in here I have return A plus B, what should be the type of add in this template? If, oh sorry, T1 and T2 T1 and T2. What should be the return type? If A and B are float and double, the return type is supposed to be double, right? If A and B are integer and float, the return type is float. If it's integer and integer, it's integer. So I cannot say what the output is. That's why you can actually say it's auto declare type A plus B. So now it will check the type after knowing what A and B is and set the outcome to that type. Got it? So for that reason, and also if I have something like this, you will see soon that I'm going to have a type that is 45 characters long. Okay? When I say type, it means you're going to say, I want a vector of threads of employees that, so you create a template that is huge, okay? And that's a type name that is like 40 characters. Then you put the function name. It makes it difficult to read. So it's always better to say auto function name that returns that ginormous type. And that makes it more readable and clear. And that's another reason. But anyways, so if you see stuff like this, don't be surprised. It's a very simple thing. Just I'm saying what the return type is at the end. It's called trailing return type. Are we okay with this? Okay. Now let me bring that thing in that I wanted to talk about. So, and then you can go for a break. So getInt is a foolproof integer reception from console input. What it does, it says, do get an integer. If scene failed, clear it and say invalid integer, and then go back. So that's that. And then goes back, okay? Does anybody have any question? I'm trying to see whose microphone I'm supposed to mute. Somebody has turned on their microphone. Here. Okay, thank you. Okay. All right. So back to business. So what I was saying, so first I get an integer. If it fails, I'm going to clear the, I'm going to apologize. I'm sorry, I put something wrong. Invalid. Then it jumps to the end of the loop. It is not done. It goes back up. It first ignores 10,000 characters up to \n, then it goes back up. If it doesn't fail, then I come over here. I take a peek and look at the character that is coming after. If after the integer, it's new line, it means that's it. That's the data, we're good. But if it's not, it means the added garbage after. So it's not a valid integer. So I'm going to say only an integer number, please. Then in here, I'm going to say, is it an adult? Now this adult thingy is a validation that I'm doing up there. And then I'm going to, that validation over there is what this thing is supposed to validate. If it is an adult, done is true, then it comes over here, while ends, and it comes out. If it's not an adult, it's going to say no children or seniors permitted, it goes back up. Are we good? Right? So it's a foolproof data entry. Now, what if I wanted to get number of students? I have to change my code. I can't use the same function that I had over here. So I have to take that logic over there, the non-valid number of students, change is adult to valid number of students, and change the error message over here accordingly, right? So I had to rewrite the code. And there is no way that I can overload, so I have to change the name of the function. In here it becomes get adult age, and the other one becomes get number of students. I have to write two functions. That sucks. I don't want that, okay? For that, we're going to learn. So first, you understand what the dilemma is over here. That if I have two different logics for validation, I have to rewrite the whole function because of those two small little validations. We good? Okay. The class ends at 5 o'clock, right? 5:55. It's 4:20. Let's have 9 minutes break. We're going to start at 4:30. Cool? All right. Please remind me to resume recording. Okay, before we continue, somebody can tell me that you can hear me at home or online?
Yeah.
Thank you, perfect. All right, so the problem over here was, I started a minute early. Well, the problem over here was that the logic over here cannot be changed. You cannot change your program on the fly. It's not going to work that way. It's not like a template that the logic is the same. Even a template, the logic is constant. It changes the types. What can I do over here? It's actually a very simple solution for it, but we need to just understand the concept. Remember that when we created an array, so if I created something like, say, integer A5, what happens actually behind the scene? Do you remember that? We said when we create an integer, it's not that you actually have 5 integers in memory like that. It is 5 contiguous pieces of integer back to back, and you have one pointer somewhere called A, and that pointer is pointing to the beginning of everything. And the address of the address of the integer is kept in A. So if I actually printed A, I would get exactly where in memory that array begins. Do we remember that, hopefully? We okay? I have good news. The exact same thing happens with functions. You see that getInt? That getInt, if I print it out, it has the address, that print has the address of the logic in memory. So essentially, you are telling to the compiler to jump to that address, to the CPU, to jump to that address and continue executing line by line, byte by byte. And when it ends, it simply comes back. How can we take that to our advantage? So take a look at this. In here, I have 2 functions. One is adult, the other one is valid number of students. When you look at them, they both have identical signatures. They are exactly same type of functions. They both accept an integer, return a Boolean. Logic inside is different. What if I could create a pointer, a variable that is capable of holding the address of a function? Then if I did that, I can pass the address of validation function to the logic and tell to the logic to execute it. So let's see how we can actually do that. So say I have these 3 functions. Sum, product, and print. So what sum does, it finds the sum of 2 integers and prints it. Product finds the product of 2 integers and prints it. PRN doesn't do that at all. PRN starts from the beginning up to the count that is an integer and prints the first one over and over. Okay? But what's important for us is that the signature of the 3 are the same. The only thing that is needed for me over here is to be able to actually create a variable that is capable of holding that. So first, I write the signature. So let's call it FPTR, function pointer. Okay? So FPTR should receive 2 integers and return a void. Now, that's a prototype. That's literally a prototype of a function, so that's not going to work out. What if I put an asterisk over here to make it a pointer? Nice try, but the problem is that When you know that when the asterisk comes after the type, this is actually what happens. So it becomes a prototype of a function that returns a void pointer. I don't want that. To fix that, you put parentheses around it. Now fptr is a single variable. It's a pointer who's capable of holding the address of any function that receives 2 integers and returns nothing. So I can literally do this now. I can say fptr is equal to sum. fptr, not tpr. fptr. Now I can say fptr 10 and 20. 40 is good too. Ta-da! Sum is called. Why? Because when you bring it over here, let me run the execute the thing, and you'll see exactly what it says when you hover over it. Take a look. When I come over here, fptr is just null. It's garbage. But as soon as I do this, it says fptr is the address of fmay28.exe, which is my executable, exclamation mark sum int int. So essentially, fptr is the address of my executable in memory for the sum. So when I say fptr 1040, sum is called. Now, not only that, I can actually do this now. I can say fptr is equal to prod and do the exact same call. Now the product's got to get called. Now I can say fptr is prn and do the exact same call. And now the prn is going to get called. Take a look. Seriously. Here we go. So now 50, and now product will be called, and now prn will be called. For 3 different functions, but they are called the exact same way. Are we okay with this? This has nothing to do with C++ actually. This is day 1 C. C language since day 1 was capable of doing this. That's actually how we faked object orientation before C++. I'm that old, okay? We wanted to actually create an object-oriented program using C. What we did, because you couldn't have member functions, right? So what we did, we actually created pointer to functions inside a structure. Then we set those to the address of functions outside. And the syntax is the same. That's actually pretty cool. You can try it once. Anyway, so that's that. Okay? So yeah. You can even do crazy stuff like, I can do this. Void f array 3 int int. That's correct, right? Did I do the syntax wrong? I don't think so. No, that's correct. So 3, and I would say, what's going on? Stop. Oh, it's halfway through execution, I think. How do I stop the thing? Something's happening here. Okay, let me maximize it. There we go. That's what I want. Thank you. Okay. So now in here, I'm going to say equals to, open a curly bracket, and I'm going to put over here sum prod, and what is the other one? PRN. So now I have an array of 3 functions. Now I can say over here for int I set to 0 I less than 3 and I plus plus. Now I can do f array I 10 and I don't know 50 and 10. And running those will actually run 3 functions back to back. There you go. You see the first one is that, 500. Then what did I do? Something's missing here. What did I do wrong?
We have 60 and 500 in the open.
Did we? Let me just. I just want to see what I had over there.
60 is after the last item of 10, and then 500.
Line number? What's going on here? Let me just see what did I do? So I created 3 sum product. 0 is the first one. Sometimes I go blind. I don't know what's going on. Give me a second. Let me see, just run it and see what's going on here. Oh, there we go. Yeah, so I didn't see the 60. Sorry about that. So I have to go to a new line to. Oh, that's why. Shoot, I forgot to put new line in here. Sorry, I just wasn't seeing it. There you go. That's better. Okay, now we're okay. All right. Anyways. So now we know, okay? Okay, so that's 04 function pointer syntax. Now that we have that, let's open this. First thing we had, where is it? Which is this one. Copy it and bring it in PRG. Okay, first of all, I'm going to remove this. I'm going to say invalid value because I don't have a specific thing. We're going to fix that, don't worry, but for now let's do it like this. Now in here I'm going to say my getInt receives a Boolean, or you can say auto, Boolean, auto, what do I call it? Let's write the normal one, then we're going to write. So Boolean is valid. That receives an integer, right? So essentially, I could write over here auto Boolean, right? Same thing, no difference. But we could do this, but just to, is everybody confused if I do this? Or are we okay? Are we okay? Anybody okay? Anybody have a problem with what I wrote over here? So it's valid is essentially a pointer to a function now. Now, in here, instead of writing is adult, I'm going to say is valid. So to the eyes of the function, nothing's different. It's calling a validation function. But in main, of course, I have to fix this. Have the same prototype in here, right? But now in here, I'm going to say age, and in here, all I need to say is adult. Just pass the name of the function. Just pass the address. I'm not calling the function, I'm passing its address. And I can have another one. Whoop. Enter number of students. And in here, I'm going to have valid number of students. And I'm going to say over here, of course, STNO. Number of students. And in here, I'm going to put student number. So now, for each validation, it's going to call the proper thing. When it's age, in here, enter your age. I'm going to put over here 200. Or no, I'm going to put over here 80, and that's fine. Oh, invalid. Invalid, valid. What did I write over there? my brain says something and my hands does something else. Invalid value. Okay. Invalid valid. Okay. Age, I'm going to put over here 50, and it's okay. Now if I put 50 over here, that's invalid because this one is number of students, and now I put 30 and it passes. So I can change the different things. Okay? That's pointed to functions, and again, it has nothing to do with C++. It is C language. Are we okay with this? So this is how C language So the better way of writing that is this. Well, I said we're going to fix it. So since now I can write the function for any type of thing that I want, what I'm going to say is that, hey, if you are using my getInt, your validation number is supposed to validate the value. After doing that, if anything's wrong with the value, set a reference of a string to the error message so I know what the error message is. Okay? Now, in getInt in here, sorry, I have to answer this question, this phone. My apologies. I have to pause. Okay, so yeah. So now I can actually ask them to do something like that, to design their validation any way I want, and I just received that type of a thing. Now I can have a proper error shown. So essentially I do the validation, I pass the number to validate, and I'm passing a reference for an error message to be printed. If something goes wrong, I'm going to show that error message, and that error message is set to whatever error I have. Life is beautiful. Now I can have logic, use different logic based on circumstances, just by the address of the function. And this is pointer to functions. Use beta. Okay? But this is extremely structured. I am creating a function, people, and standalone function and pass it around. That's against object orientation. So how did C++ fix this thing? We need the same thing in C++. I need to be able to pass logic to other logics to be able to change things that I want. I need to do the exact same thing. So what did they do? They said, wait a minute, don't we have operator overloading? We do, right? Like I can create a class. You remember the integer array that I created? I created a class. I overloaded the index operator. And my class looked like an array, right? What I can do, I can create a class. I can overload the function call operator. What is a function call operator? Parentheses, right? I can overload the function call operator. Now my object is going to act like a function. And since I have an object, I can pass the object around. As easy as that. So how do I do that? How do I do that? Say, I want to do addition, add two numbers, and see how many times it's done. Okay? In C language, how did we do that? We create a function, we put a static variable in there, right? Yeah, and anyways. So what we're going to do in here, I'm going to create a class, and I'm going to call it addition. Okay? In this addition, I'm going to say size t. number of calls. And I'm going to set it to 0. Are we okay? Then I'm going to say public. Now in here, I'm going to say int operator. So this operator of mine is supposed to return an integer, right? And then what I'm going to say function call. And now I'm going to say what the signature is. Integer A, integer B. And in here, I'm going to say m number of calls plus plus. And in here, I'm going to say return A plus B. Now I'll come down, and I'm going to say size t, number of calls, const, and I'm going to say return the number of calls. So what happens? How do I call this thing? Int main. I'm going to say addition, add. So add becomes an instance of addition, right? To call an operator, what do? Exactly like index, that I put the index and I put a number in it. In here, I'm going to say, wait, let's write something over here. I'm going to int x, y, and z. Now I can say x is equal to add y and z. So essentially, this object's function call operator will be called with 2 integers. Ta-da! Goes over there, runs that, returns it, and adds it. So, and that add thingy, then I can do this. I can actually, now I can say cout, add is called. Remember, add is not a function. It's a class. It's an object. So I'm going to say add dot number of calls. Ta-da. Add is called. I could have printed the message better. Times. Obviously, x is that. I'm not going to. We're good with this? And yeah. Let's do it. I'm going to say. And to show you that how it calls, it's actually very simple and straightforward. So add is created, everything is done. And when the function calls it done, it just simply goes over there and runs for that function and comes out and so on and so forth. Are we good? These are called function objects or functors. Okay? They don't have to be as specifically written to do this. You can have a function class that does 50 different things, and then you overload the function call operator to for some purpose. Okay? A functor is just the class that implements the function call operator. And you can have many, as you can overload regular functions, you can overload the function call too. I can have 2 doubles over here. So I can have, so if I want to, I can actually do this. It doesn't make any difference. Same thing, doesn't make any difference. You can overload that one too. Are we good? All right. So these are called functors, and we can use them, and I'm going to show you actually how it's done. So how it's used. So 07. So in here, I'm going to say functors. What is that? There we go. We don't need that. Just to make things more spicy over here, this is what I'm going to do. Okay? So when the functions are very small and you just want to write it and run it for once. Let's say for that validation thing, what was is adult? It was just comparing, like checking the value to be between two things. For that, I had to write a separate function, put a prototype for it. You can actually create very small little functions and keep them in variables, like literally. So what you can do, like for example, I can say, if I want to add two numbers, okay, or if I want to check validity of an integer to see if it's between 10 and 20, how do you write that function? You write that function like this. So you're essentially saying Boolean valid integer value, right? You do this, and then you write over here return value greater than or equal to 0. Let's say it's a mark, okay? And a value being less than or equal to 100, right? But this is a very small thing. I don't want to write a separate function. And I just want to use it in this main and be done with it. How do you do that? You write auto, okay? And then you write the name of the thing that you want. So it's going to be valid. You write valid, okay? Then you're going to say equal to. Now you write the function. How do you write the function? You put a square bracket. It's called a capture. We're going to see later on what it is. And then you start writing a function as if you are writing it. So in here, I'm going to say int value. And you put the same thing that you had over here, everything that you had. That's it. Now, this is called the lambda expression. Usually when they're very short like this, they don't even bother. They just do it like that. So essentially now, valid is a function that accepts a value. And when I say auto, because it is returning actually a Boolean, it knows it is Boolean. If you want to force it to be a specific return value, like for example, if I wanted to return a number, and if number is positive, if number is non-zero, it's Boolean, and 0, it's false, then you have to actually, if you don't do that, then it's going to think it's an integer. If you want to force it to a Boolean to make sure it actually returns a Boolean, then you can say over here, and that's actually why trailing return types were created. So you can create lambda expressions. We're OK down to this point? Now, having something like this, think about it for a second. If I go to the, so this is lambda syntax. So in here I can say if valid, I don't know, 20, 30, and I'm going to say cout 30 is between 0 and 100. So that's the syntax of lambda. I'm going to go through details of it to see exactly what it is and how it works. But just quickly, I'm going to go back. So this is lambda syntax I'm going to write. 08 lambda basic syntax. Now I'm going to go back to our first example over there. Where is it? Where is it? See, in here in main, I want to do for is adult, right? I want to do is adult. Why do I write all this stuff over here? I don't need to. If I want is adult to be a thing, all I need to do over here is to say, do like that, right? And then what do I write over here? I'm going to write, it receives an integer, right? Integer value. And I'm going to start coding. I'm going to say return val greater than or equal to 18 and val less than or equal to, what is that, 65, something like that, right? And semicolon. And there you go. I don't need to write a function anymore. Because it's a small validation thing, I just got to pass it and be done with it. Write it as a variable. Why do I write a function up there? It makes my life easier, right? And the exact same thing over here. If I want the number of students to be this, it's the exact same thing over here. Copy. And I'm just going to write it over here, and I'm going to say it is between 10 and 35. Or 40, or whatever it is. So that's the number of students. I don't need to have that. These lambda expressions are a beautiful thing. Make your life so easy. Okay? Now, there is one thing you need to know. So in here, I'm going to say lambda in use, 0.9 lambda in use. So I'm writing different lambdas to tell you what the captures are in here, okay? Because lambdas are small functions within another scope, you need to know how they should access the neighboring variables, like a and I. Can this lambda access the a and I over here? If you put a reference over here, it means all the variables within the same scope are accessible by your lambda by reference. It means you not only can access them, but you can change their value. If you don't put anything in here, it means, and by the way, because the lambda at line 8 is creating an integer I, that I is shadowing the I outside. So the rules of shadowing exist. So it means the I outside is not accessible. When you don't write anything, it means nothing is accessible. Everything over here is private by its own. And the same thing over here. So this will have reference access to the other one. Now we come lower over here to line 17. When you write equal, it means it have value access, pass by value access. It has access to value of everything. So I again over here is shadowed. It doesn't have access. But A's value is accessible over here. If you change it, the value of A will not change outside. At line 30, when you look at ampersand I and A, it means I is accessible by reference, A is accessible by value. So you specifically mention what is accessible and what is not. And you can keep adding to all the variables that you have. I want this to be accessible by reference, this by value. Same thing over here at 38. So in here at line 46, I'm saying everything is accessible by reference except A, that is value. Okay? Now everything is by value at line 53 except I, that is by reference. And that's it. And that's how lambdas are. And go enjoy them. So all those things that I brought in, I'm going to talk about at the beginning of the thing. So I'm going to show you all these things, how they are actually used in series of projects with one class called int that represents a validated integer. And we're going to go through them all. Yes?
Are the lambda expressions allocated in the stack?
Yes. That's yours. Okay. Are we good? All right. All right. Have yourself a beautiful, beautiful day.